Hey Algebra 2s, welcome to video learning. So here's your key for note 5-6, page 1. So we're going to get into solving some of these new kinds of equations, but first we're going to review the old. These important rules matter when we're taking the square root of both sides of the equations. If our index is even, then the answer always needs a plus or minus. If the radicand, the inside number is negative, you're going to need an I. Now, if the index is odd, you don't have to worry about that missing negative solution, so you never need a plus minus, or you're not going to need an I, because I can take the cube root of a negative value. Let's say I was taking the cube root of x was equal to -8. When I take that cube root of each side, x is simply equal to -2. So that sign is going to match the radicand, which is the inside number. So let's take a minute and talk about this when it's even. If I have a scenario where I have x squared is equal to 9, my job is to find all the values of x that make this true. So by taking the square root of each side, I recognize that x could have a value of +3 but also -3, so I need that plus minus. So this even power demands an even index, and that's what I have, that possible hidden solution. So this review of this operation is going to come into play as we continue to solve these. All right, so back to basic solving. 3 times x to the 4th is going to be equal to 48. Divide by my coefficient. So my rule of isolating my radical stands. Remember, I always want to get that part of the equation isolated and by itself. Now keep in mind, this 4th power demands that I take the 4th root, and when I do that, I recognize that x could have a positive or a negative value, so I have to remember that when I go to solve for x. Now for this one, on the other hand, when I solve, or when I divide by 3, I get x plus 1 to the 5th power is going to be equal to a negative 243. When I take the 5th root of this value, I don't have to worry about a missing positive or negative, because this negative means that I end up with that negative value. So remember, the 5th root of anything to the 5th power, these 5's cancel each other out, so x plus 1 is going to be equal to -3. When I subtract 1 from each side, I get a value of x is equal to -4. So we can find that we can take the square root of each side of an equation, and that's an easy idea for us to understand. So now we're going to talk about the inverse of that operation, and that's if I have a radical or a rational exponent, that means that I'm going to have called a radical equation. And this is the same idea. My powers of property of equality means that if A is equal to B, then I can take whatever square root, cube root, 4th root, or multiply to the 2nd, 3rd, 4th, 5th power, as long as my indexes match or my exponents match. So this property makes sense to us because we understand what we did up here. All right, so the same basic rules. We have to rewrite any rational exponents in radical form. So remember, this root is going to be our index, and this power is going to go with whatever happens with x here. This one's already rewritten for me, So I don't have to worry about that. The square root of y minus 2 minus 1 is equal to negative 5. Let's check out this one over here. The first thing I should do is divide by this 3, because this exponent only has to do with this part of the conversation, not the 3. So when I'm looking at x plus 1 to the 4/3 power, and that equals 16, I'm going to rewrite this rational exponent as a radical. So my cube goes in my index, my x plus 1 is to the 4th power, and of course my 16 stays put. So when we rewrite any rational exponents, we're going to go ahead and put them into radical form for this part. All right, isolate the radical, done. Now this conversation here about plus minus, when I do an even root, is going to come into play in a minute, not quite yet. So we'll go on with our equation solving, and I'm going to add 1 to each side, and I get my y minus 2 is equal to negative 4. Now I have my radical on one side of the equal sign so that it's isolated. My next step is to raise each side to the power of the root. I know this is a square root, so the inverse of that is going to be to square. As long as I square both sides, I'm in good shape. So now when I look at this next part, the square root of anything squared is going to be that thing. Write yourself a note down here if that doesn't make sense to you, because the square root of anything squared is going to equal to just that thing. So now I get negative 4 squared is 16. When I add 2 to each side, I'm solving for my variable, and I get a value of y is equal to 18. So it looks like good math that we did here, but the most important part of these notes is to make sure that we check for what we're going to call extraneous solutions. So we're going to take our original equation, which was the square root of y minus 2 minus 1 is equal to negative 5, and we'll go ahead and solve it by inserting the value that we got for y, 18. So as I solve this, I get the square root of 16 minus 1 is negative 5. I get 4 minus 1 is equal to negative 5. Uh-oh. Those two things are definitely not equal. So I wonder what happened. My math was all correct, but when I go up here, I realized, you know what, this kind of made me feel funny to begin with, because when I took the square root, I shouldn't have had a negative output. So what ends up happening with radicals is when we square them, we end up sometimes with an extra solution. That's our extra solution. Just the same as when I take the square root of an exponent, I might have a hidden solution. When I go ahead and I square a radical, I get an extra solution. So that's only really going to happen for the most part when I'm dealing with any time that I have an even power. Let's go ahead and check out what happens with our cube over here. When I want to eliminate this cube root, I'm going to go ahead and cube all sides. That's going to leave me with x plus 1 to the 4th power is equal to 16 to the 3rd power. Now I'll tell you what, I'm not going to bother simplifying that, because chances are I'm going to have to break it down anyway. In fact, now that I have this exponent, I'm going to go ahead and take the 4th root of this equation to solve. So the 4th root of anything to the 4th power, again, that's an inverse, so I get my value of just 1. When I take the 4th root here, I need to recognize that that's going to be plus or minus the 4th root of 16 cubed. I have to include my plus minus because my power or my index is positive, and it's even, so I have to remember there could be a negative solution. All right, when I simplify 16 cubed, that's the same as 16 times 16 times 16. That's the same as 4 times 4, 4 times 4, and 4 times 4. And these 4s can break down into 2s. Now I'm looking for 4 identical factors. I found them here with my 4s. I found them here with my 2s, and that includes my entire value under my radical sign. Make sure you know that this 16 and this cube is up tall. All right, which means I have plus or minus 4 times 2 is equal to x plus 1. So guess what this means? X plus 1 could have a value of positive 8, or x plus 1 could have a value of negative 8. So x could have a value of negative 7, positive 7 when I subtract 1 from each side. And x could have a value of negative 9 when I subtract 1 from each side. So again, before I go ahead and declare these my absolute solutions, I'm going to go ahead up and type these into the calculator and see if I get something that's true. When I go ahead and I type this into the calculator, I'm going to go ahead and say, okay, 3 times my value of x plus 1 to the 4 divided by 3 power. I'm hoping I get a 48. Bingo. Okay, now I'm going to check negative 9. 3 times negative 9 plus 1, close my parentheses, to the 4 divided by 3 power. I'm hoping for a 48. This one checks, and this one checks. All right, continue on with the back side of the notes.